Okay, so example number 6, solve for an angle given its approximate sine, cosine, or tangent value. Okay, so we are looking for something that's approximate, which means that we're not using our special angles. That will mean that you will be using your calculator, so you'll need to pull that out. And just a reminder to be sure that your calculator is in degree mode. Okay, so let's get started. Given that cos of theta equals negative 0.6753, where theta is between 0 and 360 degrees, determine the measure of theta to the nearest tenth of a degree. Okay, so our first step is to determine which quadrant our angle is in, or which quadrants. Now we know that cos of theta is negative 0.6753, and negative 0.6753 is negative, of course, which means that your cosine ratio is negative. So let's find out where cos is negative. All right, so let's draw our cast diagram. All right, well, we know that all our trig ratios are positive in the first quadrant, and we can see that cosine is positive in the fourth quadrant. So cos will be positive in the first and the fourth quadrant. Only sine is positive in the third quadrant, so we're going to have a negative cos in the second quadrant. And only tangent is positive in the third quadrant, so cosine will be negative in the third quadrant. So therefore, cosine is negative in the second and third quadrant, and so theta is a second or third quadrant angle. Okay, the next thing we want to do is determine our reference angle. And remember, our reference angle needs to be between 0 and 90 degrees, so we are going to rewrite cos of theta as positive 0.6753 because I want to find a first quadrant angle, because that's going to give me my reference angle. So cos theta subscript r will be 0.6753. So theta subscript r is going to be cos negative 1 of 0.6753. Okay, so recall that when you're looking for an angle measurement, you want the inverse of cosine. Okay, so we're going to put that into our calculator. We're going to go second cos to get our cos negative 1, and we're going to put in 0.6753 and hit enter, and I can see that my calculator is not in degree mode, so let's do that. I want to go second mode and put my calculator in degree mode. All right, let's try that again. All right, second cos 0.6753. Enter. Okay, there we go. That's better because this looks like an angle measurement, whereas this one looked kind of too small. Okay, so that means that our reference angle to the nearest tenth of a degree is 47.5 degrees. And this is approximate, okay? Because we had to round that off, right? So it's not exact. Okay, so now we want to draw our reference angles in the second and the third quadrant, because that's where our angles can be. Okay, so here is our second quadrant angle. And here is our third quadrant angle. Okay, and both of them are theta. Okay, so let's draw our reference angles in. They are between the terminal arm and the x-axis. Okay, so we'll have one right up just above the x-axis and one below, but both of these are our reference angles, which are at 47.5. Okay, so let's determine our second quadrant angle. All right, so that means our first red arrow here. Okay, we know up to here is 100, so if I minus 47.5 from 180, that should give me theta. And that gives me an angle measurement of 132.5. And then in the third quadrant, instead of minusing 47.5, I'm going to add this time because I need to go past 180 for my angle in standard position. So I need to add, right? Because the first part of my angle is 180 degrees, and then I have to add the 47.5. So this one is 180 plus 47.5 degrees, which is 227.5 degrees. Okay, and then we want to write our answer. So the solution for cos theta equals negative 0.6753, where theta is between 0 and 360 degrees, is that theta can equal 132.5 degrees, or theta can equal 227.5 degrees. Okay, and that ends our discussion for section 2.2.